you. Wish Zoom was a little more discreet about this one. Hope everybody's doing well. So before we continue with where we left off, and I was abstracting functions and kind of figuring out all the machinery that we need for that, I want to just emphasize something that was posted on Piazza, I think yesterday in the evening, about TA office hours. So you all rightly complained that TA office hours are too slow and people are waiting for a long time to get the questions answered. And don't recall what was exactly in that post, but basically the gist was asking you to help us to help you by being a little more, by first making sure that you follow the design recipe and all the kind of guidelines that we set out, and B, when you come to office hours and write down your question, trying to be as much as descriptive as possible, because then that helps TAs to kind of group questions together and maybe take a few students at a time and answer common questions in a group rather than repeating the same thing over and over again and taking an hour with, I don't know, let's say 6 people instead of taking 10 minutes, right? So that's something. If you haven't read that post, please read it and follow it, since that will help everybody. So that's that. Are there any questions? Okay, so to give a brief recap of where we got to, or what we were up to on Monday before we had to stop, we were working with abstractions. So we were learning or practicing how to abstract functions, how to abstract code that's common across different functions. So the first example that we actually did was prefixing a list of strings with a particular prefix. We wrote 2 functions that were very trivial and very similar, basically just prefixing each string in a list with by and high. We then applied the process that I kind of outlined over there to like check for the differences, abstracting the differences by taking the common expression and putting it as an argument or as a parameter to the function, recreating the original function in terms of the abstracted or the more general one. And if I wasn't lazy with writing down check expect, rerunning all the tests to see that everything still works, right? So we applied this process to the prefix with high and prefix with by. Trivially, the only thing that differs was the prefix. We were still going through the list, still prepending the prefix in front of the string. Abstracted that. Then when we got to implement a sum all and product all function, right, going through a list of numbers and either summing all the numbers up or calculating the product of all the numbers in a list, we found out that the common things, apart from being some value that we pass in, so that was the base value, we also noticed that we needed to abstract the operation, right? So we needed to pass in an operation as an argument, and for that to be, so applying the same steps, it was relatively clear that we need to do that. But what seemed a little bit off was that suddenly, instead of just having a usual value like a number, we would need a parameter that takes an operation or a function. And in fact, BSL wouldn't allow this. So what we had to do was to switch to the intermediate student language, from then on, so that we are able to pass in operations as arguments, right? And having an operation or a function as an argument is also reflected in the signature. We use square brackets to kind of enclose a, what would we call it, a sub-signature or a specific part of the signature, which just gives us the operation type, right? So we have an operation that takes two numbers and produces a number. So we reflected it in the signature. And if I remember correctly, where we left off was I posed the question, if we try to forget about the signature, if we ignore the signature up there, is there anything in the body of the function that says we can only work with numbers, list of numbers and operations that combine two numbers, right? And I don't know if I went as far as writing down an example of what I meant by that, but let me just do that. So my question was, is there anything that in the body of the function that prevents me from writing something like something like this and run it? So was there? I don't remember if we got to answer that question or not.
The signature says that it should return numbers.
Yeah, so the only thing that actually, if I try to run this, because Dr. Racket doesn't actually care about our signature, this actually works, right? The only thing that prevents us from doing that, or that stops us intellectually, is the signature, which is too restrictive. We kind of restrict ourselves by giving a signature that we expect an operation that takes two numbers, returns a number, operates on a list of numbers, but exactly the same function otherwise works for everything else. So to avoid, just because of the signature, to avoid having to write like process numbers and process strings, etc., we want a way to express a more general signature. So just like we express the process of combining the elements of a list using some operation by providing the process function, we want to express or generalize the process of specifying a signature that allows us to work on arbitrary elements. Okay? And to start off with that and to motivate it further, let's see if we can apply the same principles that were up there of like spotting the differences and abstracting the differences by passing arguments to functions. We can apply the same principle to these data definitions, which are quite the same, right? What are the differences between these three? Where do they happen? Yeah? So the most important difference is what we have as the type. So I will just highlight it using, let's say, this. Then we have the string here and the posin here. Right? So the main difference is, the only thing actually, or the most important thing, is that we differ in the type of arguments. And because of the type of arguments, we also differ in the names of our lists. Right? So I'll just highlight that. Okay. So what we really want is to abstract this into a function, and I use air quotes here, because we won't actually have a function that we can run. It's something that we process mentally to generate the actual data type that we want. So what we do, and I'll start by copying, is we want a kind of what we could call a data definition function that gives us a list of something, and we write it like this, and we give it an argument, some previous data definition, some previously defined data type, and simply replace the occurrences of the self-reference and the argument type wherever it happens. Okay. So quite a similar process to using the function. We just look for the things that are in common, look for the self-reference, and replace those things, and then we can think of the square brackets just like ordinary parentheses in BSL, where we apply a function to an argument. Here we apply a signature generator to an argument if we want. Okay. Then we can express all the other ones simply as list of number, list of string, and list of boson. Right? So we have a question. Can the name of the list be anything, or do we need to use the words list of exactly to set up a list of X? So we need to agree that this is the kind of the operation or the signature operation that generates the data definition for us. Okay, so we cannot just pick this arbitrarily. If we define what we call a generic list, so a list of an arbitrary element type as this, then we need to use the same name, if that makes sense. Okay, so think of this just like you would of a function definition. So then every time you refer to this, you have to use that name. Okay, so we have that expanded to the one below. We have this, and we have list of bosons. Okay. Where it becomes again useful, what would the expansion of this be? What data definition are we expressing here? So to actually get this, okay, I have a list of numbers, right? It's either empty or it's a cons, where I need a definition for list of numbers to give it, and then the rest is list of numbers. All right. I'm happy that I already defined list of numbers, because then I would have to go and define, give the definition just to be able to express this, right? Because I cannot do this in line. And all of this together with that definition can be simply replaced by using this line. Okay. And we will use it in signatures. You can also use it if you want for example, a name list is a list of string, for example, instead of having to say, well, a name list is an empty or it's a const string to a name list, etc. Okay, so anywhere where you would need to put this kind of is one-off, now you can put that. Here's another example. So this doesn't have to just work for lists, but we can do something like, okay, I want to have a generic way of pairing up two things. So I want to make pairs of names with booleans, maybe names with numbers, etc. So what I can do is to define a struct called pair, taking a left and right element of the pair. So that's a generic pair. Again, typo. Define struct doesn't care about the struct itself, doesn't care about the types. So I need to give it some meaning, and I can say a pair of x, y is make pair x, y, right? And then whenever I want, for example, I don't know, a directory entry is a pair of name and the number. Okay. Or a let's say name, full name is a pair of string, etc. Right? And again, I can then define generic functions that work for any pairs, and these will automatically not just work, but will have the correct signature once we get to how to define this. Any questions about this? This is slightly more abstract because we are not actually defining functions that we run and actually make things for us. Yeah?
Can you explain the syntax of like the vertical bars?
Oh, this was just my way because I cannot just circle things.
Oh, okay.
I use this just to emphasize these are the common things that we are about to replace with those X's.
Okay, but when we're actually writing stuff, we don't have to write those.
No. That was just randomly picked some character to emphasize what I was talking about. Any other questions? Okay. So now let's go back and I'll copy this and we'll try to make it a little more general. So we know that we will take in an operation that takes something, takes two of something and returns something. Then we need the type for the base case. We need the list and we need the number. Okay, let me kind of separate this over here. So need to fill in some blanks. Okay, so I said that I want this function to work for lists of arbitrary elements. So I don't want to care about the type as long as everything else works out. So we just defined a notation for that, and I'll make it generic by saying list of X. Okay. What is the type of the base case? Let me change the names in the process. So base, list. I'll replace them in the body later. Yeah?
Base case would just be some value of X.
So it would be, it can be, yeah, some value of x. Okay. What is the type of the operation? Or first, what do we actually return from this function? So we filled in some blanks here, right? We have a list of x, and we have an x, we decided. What is the return type? Yeah? It's an x again, okay. So we now know that in the base case, we return the base. Uncased, we take the first one, combined with the rest. Okay, so the type of first is what in here? Yeah? It's an x, yeah, because we have a list of x, so the element actually has to be x, so this thing is an x. Now process, if everything else fits, also returns an x. So that means that this operation needs to take an x and an x, right? And for the rest to work out, because this is what we return from a function that is supposed to return an x, the return type of operation also needs to be an x. Okay. Everybody happy with this? Seems general, seems to fit. Now, sum all, right? If we just take x to be a number, we replace number, 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 list of number, and number. And we get basically the previous signature back. If we apply it to strings over here, right? What we have to do, so string append is a function that in the simplified case, even though it can take more arguments, if we just use it on 2 arguments, takes a string and a string and returns a string. So that means that x needs to be string because we need to make this work, right? Then all x's need to be a string. That works out. Okay. Now, again, in the body, so let's say that I write the following function. So I say add length, and it will take a string and a number and return a number. And the idea of this function is add the length of the given string to the given length so far. Okay, so all it does is SL plus string length S to L. Okay, might seem a little odd so far, but the way I want to use it is add length 0, and let's use my previous list. Okay. So what I'm defining now is calculating the overall length of all the strings that are in the list. Let's say is list of string returns a number. Can I do this? And this is, again, there are two questions. Does the signature allow me to do this? Does the body of the functions or the functionality itself, if we forget about the signature, does it allow me to do this? Let's try to run this. So if I run this, right? I get a result back, which seems to be hello is 5, world is 5. So that's 10, that's 2 here, 12, 13. Seems to work okay. Yeah? Yeah, so can you repeat that?
So like if the parameter is a list of string, it has to also return the string.
Yeah, exactly. So currently our signature says that whatever the list is, that's the type that whatever the list element is, that's the type that we return. So if we actually try to make this fit the signature, we get something like, okay, so we give it a base that's a number, right? So that's where the 0 comes from. So that means that, that means that x must be a number. But then we also give it a list of strings. So that means that x must be a string, right? Which is not possible. I don't follow. Sam, I don't follow what you mean by that. Yeah, please unmute yourself.
Can you hear me?
Yeah.
Yeah, so basically what I thought was going to happen is so we're defining the function add length as add length SL, and then inside that function, we add string length of S and L. And then if we go into the next function, overall length LOS, we do process add length 0 LOS, which wouldn't that make 0 S and LOSL? And we're doing string length of S, so wouldn't that be string length of 0 and then LOS? I'm a little bit confused by the syntax.
So add length takes two arguments. The way we use it in process, right? Let me actually copy the body of process so that we can expand this. So this is the same as using const empty base, and base here is 0, right? We have add length of first of list, which is a string, and then process should return whatever the type of the second argument is. So if I do add length 0. Does this help, Sam?
I said it helps. Because we're running process add length is the operation.
Yes.
Okay. Yeah. Yep. I get it now. For whatever reason, I thought like add length was a separate function, but that makes total sense to me now. Thank you for the clarification.
Yeah, of course. Any other questions at this point? So we definitely cannot make x be both number and string, like, right? That won't work. How can we fix this? Charlie?
Can we change our signature to reflect what we actually want?
Yeah? Which
So,
one?
For current case, we use numbers, but is it all right if we use any, which is we used it earlier in the year as a keyword to mean any like type, data type.
Yeah, we can like plug in any, but that makes the
Okay.
signature pretty close to useless actually.
So we have the one number, right, where we already have one of them plugged in as number. If you look down in process, scroll down a little bit.
Yeah?
Yeah. So we have the first part of that signature says X and X go in and turns into X as well.
Uh-huh.
And what we actually do, right, if we look at, where is it? Add length is we add, or the first argument we pass is X, but the second one is a number instead.
Mm-hmm.
And the output of that is also a number.
Right.
So we change those two.
So we want something like this, and this returns a number. Yeah?
Yeah.
Yeah. So this is what we want, but it's not what the signature of process allows us to do. Right? Any simple fixes that we can do to the signature, yeah?
If we make a function that turns, like, takes all of the string and lists string and turns it into a list of numbers first.
Yeah, we could try to like fool around with how we actually express this function, but my point is that there's nothing inside of process that actually prevents us from doing this, right? It runs okay. It runs perfectly fine. And we have a suggestion online actually. What we can do is, again, not restrict ourselves so much, because actually the return type of this function is determined by the type of base and the type of what this operation returns, right? So if I change this to another variable, that means that I also need to change this because I return base over here. I also need to change the return type of the operation because that's what the return type of this is, right? So now both the empty case and the cons case will return y. And to make this work, so that's also this one. To make this work, well, the first argument of the operation needs to be the element type, so this is still x. Process returns a y, so the operation better be able to take a y here and return a y here. Okay? Because there is nothing that says just because I take a list of x, I need to return an x type, other than what the base is and what the operation does. The operation is actually the thing that restricts the type, right? That determines. If I pass in plus, then both types are the same, and this is the same type. If I pass in at length, then this is string, this is number, has to return a number. Then it needs to take a number as the base, needs to take a list of strings, and will return a number. Okay, so as soon as we generalize that, then if I do the exercise again, since add length is string and number, that means that x must be string and y must be number. And if I try that, everything actually works out, right? I just plug in the two things. Now I'm not restricted for having this and this and this, everything the same type. I'm a little bit freer now. And it works. Yeah?
Would it not matter then for like the sum function if x and y are both numbers?
No, because for the sum function, again, I have more freedom now. There's nothing that prevents me to say, in this case, actually, we are passing in plus, which for simplicity reasons, let's say that plus is just an operation that takes in two numbers and returns a number, right? So I can simply say, oh, okay, so x will be a number, because that's the first argument. But I'll also make y a number. And then we still have everything. Working out. If simply pick the same thing for both of the. Okay. Yeah.
When you say x, y, arrow y, are you explicitly saying that the return type has to be the same as the second argument?
Mm-hmm. So the.
So what if we wanted to use process on a function that like takes a number as the first argument, a string as the second, and returns a number?
Then you need to do something to switch that.
Could we say like x, y returns z such that z is x or y?
xy returns z such that xy is
Such that z is x or y.
such that z is x or y.
Yeah.
Okay, what is the return type of?
Or well, it's the same in this. Oh, that would be z then. That y would be z.
Yeah.
Yeah.
So this would be z. Then this one would have to be z,
Yeah.
right? And then y is like, this is just some arbitrary, and we don't gain anything from doing that. Any other questions?
But wouldn't that be invalid if we pass something that doesn't fit that x, y returns y? If we had like y x returns y.
Yeah, so it would be, but the point is that if I wanted to do something like this, so let's say that I actually flip the arguments here, right?
Yeah.
Now, where was it? This one. If I try to run this, it no longer works with the body of a function, and our signature actually prevents that.
Okay.
It dictates
I
the
thought
order.
You used the wrong function there, though. You just changed the half life.
Yeah, I did what you said. I just flipped the arguments.
Or you called the wrong function in like the REFL. You said overall length instead of that length.
Well, but
Oh, they just called it. Okay.
yeah. Okay, so the signature actually prevents that, because the order of the arguments that we use inside of the function, if we flip the arguments, where is some definition of process? If we flip the arguments here for the function, we also need to change the order in which we apply them. Okay. Okay. So we now have one more thing that I almost forgot. So one thing that we need to add to this signature is basically say what we mean by x and y. Okay? What we want to prevent is suddenly plugging in somewhere, putting in a signature like x is one of, which then means that this x is actually a very specific specific data type, right? So what we want to say there, for any type X and any type Y, this is the signature. And the notation for this is X, Y, either using curly braces. Some people use parentheses. Okay. So what this says, X and Y are type variables. They are not specific types. So even if there is an X defined before, it's not this X. Right? If you're familiar with predicate logic, the way you read this is for all X and Y, this is the type. So for any X and Y, I can specify this type. Okay. So this way we have generic signatures that don't get messed up if we do have a type that happens to have the same name. Okay. Just remember, whenever you use a type variable, use this thing. Okay. Now, just to kind of hammer home how process actually works and something actually about the usefulness of process. So we derived process because we found that this actually represents a pattern that comes up quite often when we process lists. We have a list of something, we have an operation that combines any two elements of a list into something, and we kind of want to process the whole thing. This is such a useful thing that there is a function for this in ISL already. And then that function that we call process is called foldr. Okay? Foldr because it's a shorthand for write fold. Fold being the action of combining a list of element by element, and write because we're actually combining from the right side of the list. Okay, and what I mean by this, let's just make an example list. B cons C cons D and empty. All right, and let's say that we want to run process with some function and some base, meaning that I'm doing this. Okay. And I'll just replace, like go down the list and show how we actually replace each cons with an application of the function. So the first step that happens is we are in the cons case, right? So the argument is a cons that contains a first element. What we do is we apply the operation to the first element and the processing of the rest. So what happens here is we do this and this, right? And let me delete this for now. So this is what we get after the first step. Then we are still have a cons here. So what we do is we apply the function f and process the rest of the list. Okay, everybody still with me? With what's going on? No? So what we're doing here is showing what we get if we apply this function to some list, right? At each step, we look whether we are in the empty case or in the cons case. Since we were in the cons case at the beginning, and the function that we are applied that is up here is an f, we apply f to the first argument and process the rest of the list. So let me bring that back. Right? The rest of the given list is cons b, cons c, cons d. So we call process with F on that one. Okay, so that's after the first step. Now if we go one step further, we apply F to the second element and still process the rest of the list. If we then go one step further, we apply F to the third element, process the rest of the list. Then we apply this to the fourth element, and we are presented with an empty list as the last case. So if process gets the empty list, it just returns whatever the base argument is. So this whole thing gets replaced with base. Right? And to actually compute the result of the whole thing, we need to start from the innermost expression. So we combine the last element with base, then we combine the result of that with C, then we combine the result of that with B, and finally we combine the result of that with A. Okay, and that's why we are we are folding from the right, because the first thing that we combine with the base is actually the rightmost element. Okay. Symmetrically, to fold R, there's a fold L that does the same thing, but starts from the left. Okay, and I won't go into detail of that one. We don't need it right now. But that one works by combining A with base first, then combining the result of that, and finally combining the result of D. Okay. But let's just keep it to fold R for now, or process. Okay, so just to hammer this home, you don't have to define process whenever you need to use something like this. You can just replace it with fold R, and it will work exactly the same. Right, I switched the arguments here. Let me just put it back. No, that was good. Okay, any questions about process of fold? Right, let's do one more exercise, and what I'll want to do is to design a function to which we pass a list of stars, right? And it simply renders the stars on a blue sky. So we have a bright background with a blue sky. We have the image of a star, which is a solid white. So how would we, and here's an example, we simply represent stars as positions, okay? So how would we go about defining this function? What would be a good signature for this one? Yeah? So it takes in a list of stars, and we said a star is a boson. So let's just do that, and returns returns an image. Okay. So we have a list of stars. What do we do inside of this function? Can we use process or folder to define this function? Probably yes, because this is why I'm asking it right after we talked about it for a while, right? So we want to do something with the list of stars, right? And I said that we might be able to define a folder. Let's stick with process for now, because I think most people are most familiar with it. What do we pass in?
So
Charlie?
I think our first argument is like the actual function we need to do. So I think we make kind of a wish list function that places a single star, like a place star,
Okay, so place star.
which takes a star which we define as a positive.
Yeah, takes a star
Yeah.
and
Outputs image.
an image, and we want to plug this in as the argument too.
Function.
Okay, can we do that right now? Does the signature fit? No. Process expects a function that takes two arguments, right? We are only giving it one. What is the second argument? Josh? The background, which is an image, exactly. So to make this process of folder work, we need placeStar to take a star, which is the list of star thing there, and it needs to take an image, because that's what we are eventually returning, right? And return an image. Okay, so let's say that we have this function. What's the base for folder or process? So a suggestion online says background, which is exactly that, right? We want to fold all the stars, so put all the stars in the list eventually over the background. So this should work if we get a correct place star definition. Place star takes in a star and an image. What's the body of this function? So since we are taking a poson, we can kind of outline the template. For a star, yeah?
Would it be place image and star,
Uh-huh.
constant stars,
Star.
and then positive X, positive Y, and
Yep.
then it would be image.
Yeah.
Star.
Uh-huh. So let's see if this actually works out. And I had a list of posons prepared. And this works. Okay. And again, why does it work? I have a list of 3 posons here. Let me copy it and say this is cons, and cons. Added to an empty list, right? as soon as process gets a hold of this, again, the principle that I kind of wanted you to remember from the little example I gave above. Oh, I wish it wasn't so far above. Is that what process of Oldar essentially does is every time there's a cons, we simply replace it with an application of f to the element and the rest of the list. And if we see an empty, we replace it with the base, right? So scrolling back down, what happens here if I star run this is eventually this gets replaced with draw star, sorry, that was play star. Every cons becomes a place star. And every empty, well, there's only one empty, becomes the base case, which is background in this case, right? So after process runs all the way down to this list, this is the expression that we then finally need to evaluate. And to evaluate it, we first need to place the last star over the background. Then we place the penultimate star over the last star in the background. And finally, we place the first star over the image that was produced from that. Okay? Any questions? Make sense? Okay, so here's a little kind of lighter ending. So let's say that I'm writing a game, and for some reason I want a background that has just 100 of stars, right? At random positions. I definitely don't want to sit down and write down a list of 100 stars. Seems like a waste of time. Especially if I don't care where they're actually positioned and I kind of want it to appear like a star. So I want to have a function that allows me to generate a random star. So the first thing that we kind of need, I don't know if you know, there's a random function in the library or in ISL that just generates a random number, right? You give it an argument, which is the upper bound, and it will generate a random number between 0 and that upper bound, okay? So that's one piece of the puzzle. Now, how do I build a list of an arbitrary length? Turns out there's a nice, nifty function for this, again in ISL, which is called build list, which allows me to build a list of an arbitrary length. Okay. Now, the signature for this function might be a little bit confusing at first. So what it takes is a number, which gives me the number of elements that I want. And it takes a function from a number to some element. Sorry, without this other arrow. Switching languages is really hard. And returns a list of x. Now, any ideas what this function means? Why is it taking a function from a number to an x and returns a list of x? Any ideas? Yeah?
The number that you put in is the upper limit of.
Sorry, can you
The
repeat
number
that?
that you put in is the upper limit of the random function, and then use that to create.
Okay, so this is how many elements I want, right? But what is the number that this function takes? The upper bound? Why would it take the upper bound?
Because I thought that if you put that one in, then it'll give back a random number, and you can use those as like limits to the star.
Not quite. So I talked about random, but actually build list doesn't have anything to do with random at this point. Now, what about this? Build list. So I want 5 elements, and I'm passing in the function at 1, which just adds 1 to its element, right? At 1 is number to number. What will I get back? What do you think? Yeah?
So it's taking the last thing that's put to the list and the function decide how to make the next one.
So if it was taking the last element or any element in the list, this couldn't be number because the element type is X, right? What it does instead is it will go through from 0 to this number minus 5. So let me and if I have a list of if I have a function here, what it does is it builds a list that has f of 0, f of 1, and finally f of n minus 1 in it. Okay. So this function can be thought as a generator, right? It gets a number, it generates a list. Another example is, for example, if I pass in 10 and the square function as the argument, what will I get back? Yeah? Yeah, the squares of the numbers from 0 to 9. Okay, so it generates that. How are we on time? Pretty close. So now what I want to do is to generate my stars, but my stars should be random. Can I do it using build list? Charlie?
I think you can. You might just have to be a little creative about it.
Okay. How creative?
So it basically gives you the index you're putting in,
Uh-huh.
but you don't necessarily, like, you can just randomly generate instead of using that index.
Exactly.
Take that number and then disregard it, basically, and then randomly generate the x and y for your star.
Exactly. So the function doesn't care what I do with the number, right? I just need to take a number. So if I want to generate a list of random stars, and let's say 100, and I want some function called random star, all it needs to do is take in a number and generate an element. And I can simply generate an element by making a boson where the x-coordinate is between 0 and 300, because that's the width of my background. And the y-coordinate is between 0 and 200, because that's the height of my background. Right? Now if I run this, don't you know you're supposed to ignore that? if I run this, I get a nice collection of 100 random positions, right? And again, although I have a function that takes in a number, so actually it doesn't matter what it takes in this case takes in a number, it does return a poson, which is what I needed, right? It just happens to ignore the number. So I get my 100 stars, and I can just draw them. And I get a nice busy image with stars in them. Yeah?
Why do
Hello?
we need a parameter the random star?
We need a parameter because we are using it in build list, right? And build list says, I want a function that does take a number and returns an element, right? If I wrote a function that didn't take anything, then build list would try to, well, but take the 0 from me, take the 1 from me, right? So it wouldn't work out, it would break. So to fulfill the wishes of build list, we need to actually write a function which just takes a number and throws it away. I don't care. Okay, yeah?
Is this like the closest we're gonna get to loops?
To loops? We already did a lot of looping. We just did it via recursion. There are no loop constructs in Rackhead. Or in ISL at least. Any other questions? Oh, so the question was, I think this was for random, whether it can generate the upper bound itself. So no, it's from 0 to the argument -1. Any other questions? Yeah?
Wait, so if it's random 10, it will never output 10?
It won't output 10.
And it's only integers too, it's not...
Only integers, yeah. If you want to be sure, double check the documentation. But in most languages, whenever you have a random generator, you just give the upper bound and it generates everything below that one, up to that one. Any other things that I can? All right, sorry for going over. Thanks for coming, thanks for listening. I'll see you all tomorrow. I also have office hours from 3 today.
Thank you.